What should the mass of sodium carbonate be in order to standardize 0.1 molar HCl if 10 ml of acid is used for the titration in the methyl red endpoint? A good practice in solving these types of questions is to write out the given. So we are given that there is 0.1 molar HCl, so we should write that, 10 ml of acid, and sodium carbonate. So sodium carbonate is Na2CO3. That is going to be important later as we answer the problem. So we have 0.1 molar HCl, 10 ml of acid, which could then be converted into liters, which is 0.01 liters of acid. The problem asks what is the mass of the sodium carbonate, mass of Na2CO3. So that's usually in grams. There's grams of sodium carbonate, which will be equal to, so 0.1 molar HCl is just equal to 0.1 mole over liter of HCl. So we have to cancel the units of liters, so we can use the acid. So we have 0.01 liters of acid over 1. And from here, let us remember that Na2CO3 in relation with HCl, the stoichiometry relationship is that for every mole of sodium carbonate, there are 2 moles of HCl. And a quick Google search can just tell us that the molar mass of Na2CO3 is equal to 105.99. Well, let's just round this up. 105.99 grams. So in order to cancel the units, you can write 105.99 grams of Na2CO3 for every mole of sodium carbonate. From there, let's check if we can get the grams that we want to achieve at the end. So we have the mole of HCl, we can cancel that out. We have liters of acid, we can also cancel that out. And then there's moles of Na2CO3, we can cancel that out too. And we're left with grams of Na2CO3, which means that we've done the correct procedure. So let's just plug that in our calculator, and that will give us 0.052995 grams of Na2CO3. But if we're going to follow the least number of significant figures, we have 4 significant figures. So we can convert that and we'll have 0.05300 grams Na2CO3. But if we're not considering significant figures, we can just leave it as it is, which is this one right here.